Example 3. Find the area of the region R between the graph of f of x equals 1 over square root 9 minus x squared and the x-axis on the interval -3 to 3. And it can be represented by the definite integral from -3 to 3 of the function 1 over square root of 9 minus x squared with respect to x. And this function is an even function. We can use the even function property of the definite integral from point a to negative a to a by rewriting as the twice of a half, which is from 0 to 3 of 1 over square root of 9 minus x squared with respect to x. Once we get into this form, we can see that the function is continuous at the lower limit 0, but not continuous at the upper limit x equals 3. From the real number line, to represent the interval of integration from 0 to 3. Continuous at 0, but not at 3. Use the point B on the left side of the 3. Take the limit as b approaches 3 from the left. Therefore, this improper integral is written as 2 times the limit of the definite integral from 0 to b as b approaches 3 from the left. The integrand is 1 over square root of 9 minus x squared with respect to x. This integration, we see the pattern of the number squared minus the variable squared, which is 3 squared minus x squared for our case. We're going to use the trig sub technique. And then draw the right triangle diagram. Angle theta. When you have the difference of the two squared, the first term squared would represent the side of the longest side, which is the hypotenuse. So in this case, we have the hypotenuse as a 3. And x is the opposite. Therefore, the adjacent is 3 squared minus x squared, which is 9 minus x squared. Form the relationship of the x and 3. X over 3, which is the opposite over hypotenuse of the sine function or sine theta. We can write x as 3 multiplied by sine theta. Find differential x, which is 3 times cosine theta d theta. Therefore, the integral of 1 over square root of 9 minus x squared with respect to x can use the use of technique by rewriting everything in terms of theta and the trig function. The dx is 3 times cosine theta d theta, and the denominator as the square root of 9 minus the x squared, which is 9 sine squared theta. Simplify the denominator and write it as the common factor 9 times 1 minus sine squared theta under the square root with respect to theta. Recall 1 minus sine squared is the cosine squared theta. So then the denominator becomes 3 multiplied by cosine theta d theta. It's very nice that they are both reduced. Now we have to find the antiderivative of 1 with respect to theta, which is theta. And from the relationship of the x over 3 and x in 3, so we can see this as theta equals the inverse sine of x over 3. Back to the main part of the integration. So the improper integral is 2 times the limit b approaches 3 negative. The antiderivative that we just got is the inverse sine of x over 3. Evaluate from 0 to b. Substitute the upper limit, the inverse sine of b over 3 minus the substitution using the lower limit, which is the inverse sine of 0 over 3 or just 0. The value inverse sine of 0 is 0. For the inverse sine of b over 3, that approaching the inverse sine of 1 negative. And inverse sine of 1 negative, think about the graph of the sine function. It approaching 1 when it approaching pi over 2, but 1 negative, that means from the left side of negative. So that means this value approaching pi over 2 from the negative side or approaching pi over 2, we can say that. Then the limit value becomes pi over 2 multiplied by the coefficient 2. The answer is pi, which is the finite number.